Hi, my name is Bahadur Akhmedov. Welcome to the course of Probability and Statistics. In this lecture, we're going to discuss about the expected value. What is this, how to use this, and how to calculate this. And I would like to start my lecture from an experiment of rolling a die. So we know that this is kind of the probabilistic experiment. Whenever you roll a die, you're going to get the result, which is the random variable. So you might get 6, you might get 1, or you might get let's say 3 with the equal outcomes. And our ultimate goal for this lecture would be to calculate the expected value of this random variable. So let's do this. So first of all, what I would like to do is I would like to write the distribution table of this random variable. So let's say x is going to be the random variable, which is going to be the output of this experiment of rolling a die, and you might get 1 or 2 or 3, 4, 5, or 6. If this is a fair die, then the chances of getting any value are equal. So that is why their probabilities are equal as well. So that is why probability of getting 1 is going to be 1 over 6, 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 and 1 over 6. The reason why I'm getting this 1 over 6 is that the sum of all the probabilities should be equal to the 1. Right? Okay, so I would like to find the expected value for x or of x, and we are going to denote the expected value as the e of x, where x is going to be in the rectangular brackets. So I would like to give you a small spoiler. So the expected value basically mean the average value of x. So if you are given a couple of numbers, like 3 numbers, finding the average of the 3 numbers would be easy. You just sum them and divide them to the 3. But how to find the average value of a random variable with some distribution? So in order to do this, let me give you a couple of examples. So let's start with an example of exam results. So let's say we've got an exam with the and after the exam, we have the list of results for the 10 students. The results of 10 students. So they are given in this form, like 10, 10, 20, 20, 20, 30, 30, 30, 40, and 40. So they are the results of the 10 students. So if you would like to find the, so let's call them as x1, x2, x3, and so on, x10. If you would like to find the average result of this group of students from this exam, what you're going to do is you're going to just sum all the 10 results, where I goes from 1 to the 10, and divide them to the 10. Right? So at the same time, you can do this a little bit different, conceptually different. So what I'm going to do is I would like to create the frequency table. So a frequency table means that I would like to find the values, for example 10, and I would like to find its frequency. So how many times this 10 has appeared in my data set. So there are 2 appearances of the 10, so that is why I'm going to write down here the frequency of the 10 is 2. So here we have 20 as well, and there are 1, 2, 3 appearances of the 20, so obviously we're going to write down 3 to here. So the 30 has the appearances 3 times, and 40 has the appearances of 2 times. So hopefully you understand what does it mean, the frequency table. So the frequency table just basically tells you how many times that your values are appearing in the data set. For example, 20 has appeared in the data set 3 times. So it is possible to calculate the same value from the frequency table. So if you remember, in order to find the average of the results for these 10 students, you just need to sum of all the results and then divide this to the 10, right? So what we did is, so you are going to have 10. So you need to sum 10 and 10. Instead of doing this, you're going to just multiply 10 to the 2, which is the appearance of the 10. So let me write here. So 10 times 2 plus 20. So we have to sum 23 times, or it is equivalent to just multiply the 20 to the 3. And then 30 times 3 and 40 times 2. And you have to divide this to the 10. Right? So at the same time, you can, so this is equal to the same average. So this is the same thing, right? So we are basically summing all the values and then dividing them to the 10. So now what I would like to do is I would like to divide this 10 to all the terms, all the 4 terms. I'm going to write as 10 times 2 divided to the 10 plus 20 times 3 divided to the 10 plus 30 times 3 divided to the 10 plus 40 times 2 divided to the 10. Right? So do you see? So I'm multiplying the value to some 2 divided to the 10. Right? And actually, whenever you divide, so 2 divided to the 10, or 3 divided to the 10, 3 divided to the 10, and 2 divided to the 10, actually means the probability, right? So if you remember by the definition of the probability, so this is the probability by its definition, right? So actually you are multiplying x to its probability. x1, let's say, x2 to its probability, x3 to its probability, and x4 to its probability. What we're doing is we are just multiplying the value outcome to its probability, value to its probability, value to its probability, value to its probability, and then we're summing this. This is actually, if you remember, this is the same as what we have started from the beginning. We are still finding the average result, right? So instead of finding the average result in this way, what we can do is we can find the average result by just multiplying the appearance of, so just the outcome to its probability, and we have to do this for all possible outcomes. And this is actually the definition of the expected value. So basically, if you would like to find the expected value of a random variable, what you have to do is you just need to sum xi to the p of xi, probability of this x. So n goes from 1 to the n. So I'm going to find the expected value for our example with rolling a die. So x is going to be 1, 2, 3, 4, 5, 6. And the probabilities of all of these outputs are equal to the 1 over 6 always. And I would like to find the expected value of the x. So the expected value of the x is going to be 1 multiplied to its probability 1 over 6, plus 2 multiplied to its probability, plus 3 multiplied to its probability, plus 4, 5, and 6. So since the denominators are the same for all the terms, I'm just going to sum them. So sum the numerators, 1 plus 2 plus 3 plus 4. This is actually 10, 15, 21 divided to the 6. It's going to be 21 divided to the 6, which is equal to the 3.5. Right? So this is what we have found. So the expected value of a random variable is going to be found using this formula. This is example how we can find this, and actually the expected value is the same as the average value, and we have just derived this from the definition of the average value. So in our next lectures we're going to discuss about the expected value of a function of the random variable, and also we're going to talk about the variance.